Ladies, and gentlemen. First order of business, what do you have tomorrow? A lab.
Yeah. Hey, look.
You do not have a quiz tomorrow. I repeat, this is on video, okay? Today's date is October 10th, 2019. You will not have a quiz on October 11th, 2019.
Mr. Hall, are you today's date? Because you're looking like a 10 out of 10. You got that on video, too.
Not the first person who said that to me.
You need a copyright G to that.
Alright, so, listen. I'm giving you your lab handout. I'm literally going to explain to you what you're going to do tomorrow in the lab, and I'm not going to walk you through it. You've used these techniques before, so it should not be a problem for you. So I need you to listen. Because tomorrow, whenever you come in, you're going to be going straight and getting safety goggles, aprons, and starting on the lab. That's the whole purpose. I do not want to have to spend a second day on this lab. The fun thing's going to be is I'm actually going to get some data as well, and we'll do a comparison to see whose is the best. So with this, I'm handing you out your not safety sheet. You already got that. I'm handing you out your lab handout. Please, for the love of all humanity, listen to me and what I'm going to tell you. Not everything on here is going to tell you exactly how we're going to do it. I will try and create you a data table to make your life a lot simpler for reporting. I'm putting the leads on this one as well. Okay. Alright, on this. So this is what you have done. You have voted on Survey Monkey. You all have voted for your favorite soft drinks. I will purchase those.
We did vote? Yeah, we didn't vote. Mine hasn't been through. I don't have it here.
Well, okay, not everybody voted, but about half the class voted. So we're going to go with soft drinks from that class.
Was it that monkey survey thing?
Yes.
Man, I tried to make that.
So in this, I'll pick soft drinks up. I'm going to leave it unknown. Let a little bit of suspense build. This is literally what you'll be doing tomorrow. Okay? In the back, right now you can see what looks like water inside a flask. In those, that is just not water. Every one of those is sugar water. There is a certain concentration of sugar in every one of those solutions. So the one sitting right here, that's 1%. Then back there it goes in order 5%, 10%, 15%, and 20%. You will start, well you don't have to start, but you're going to have to get the density of every one of those. Density is equal to mass over volume. So this is how you're going to do it. We want to be extremely precise and accurate when we're doing this. So what piece of glassware do you think we'll use?
Pipette.
A pipette. I'm openly saying this right now. And I know there's going to be somebody in here that's not going to listen to me and you're going to drive me nuts tomorrow. On your lab handout, anywhere it says to use a graduated cylinder and fill it to the 10 milliliters mark is not what we're doing. You are going to use a 10 milliliter pipette. It is the most accurate and precise. You will pipette these. You remember when we did the lab on determining what was the most accurate and precise glassware? And you had the pipette. And you had the beaker on the scale. And then once you had the 10 milliliters of water in it, you let it go in the beaker and you got the mass of it. You're doing the exact same thing. The only difference is the only thing you're doing is pipetting. And you're going to do this for every one of those solutions back there that I've mixed up, the 1%, 5%, 10%, 15%, and 20% sugar. And then you will also do it for the soft drinks. The whole thing we're determining is the percent sugar within our soft drinks. And it gets very, very interesting. Because tomorrow you will come in, you will also predict which one do you think has the highest sugar concentration versus the lowest sugar concentration.
I really hope we have Monster.
I will tell you this. Whenever the votes started rolling, I was shocked. I did not expect Monster to be a front runner, but I was like, whoa. So whenever the votes first started coming in, Monster was at the top.
Oh, is it on the bottom now?
Have to wait and see.
Well, are we using only one? Like, how many are we using? How many?
You will be using 4 that you voted for, and I'm picking up a 5th one
Red Bull.
Phoenix.
that I'm going to make interesting.
Probably like pomegranate.
It's gross and disgusting, and they should never admit that. So, is there anybody in here that does not know what they're going to be doing tomorrow? It is literally this simple. You come in, you get all the safety stuff on. You're going to take you a beaker. You will be going over to a scale, setting a beaker on the scale. You will hit the tare button because we don't want the mass of the beaker, right? We want the mass of the liquid we're putting in there. So whenever you're looking at this and you're looking at density, mass over volume. Where's the mass coming from?
Substance inside the beaker.
Mass of substance. I'm very impressed with you right there. That was like, you haven't been in here no time and you're just starting to make this just really scientific. Mass of the substance from the scale. In this case, what's volume? What is it? Typically would go with what you're saying, but we're using a 10 milliliter pipette. What does a 10 milliliter pipette measure?
10 milliliters.
10 milliliters. Every one of them will be 10 milliliters. I'm doing this to help you out. It's a very simple conversion. If you end up with a mass equal to 10.739 grams, what will the density of that be? How did I get that?
You moved the decimal.
No.
You did not just move the decimal. We divided by 10.
I said
It's
that.
the same thing.
No, it's not.
Yeah, it is. You get the same answer no matter what.
All right there, Patrick. Take the bottom and push it somewhere else.
It worked.
Oh yeah, it worked great.
It worked.
How'd that work out? On this is literally all you're doing the whole time. This is it. 1% sugar solution, 10 milliliters in the beaker. Get the mass of it. Does anybody in here not have any clue what you're going to do tomorrow? I'm openly asking you right now. I am willing to answer the questions you have right now, because tomorrow whenever everybody comes in here and they stand there and they go,
What's the tera button?
Mr. Hall, how do we do this?
Hey, I kind of know
What?
like, I thought volume was like,
Just the
wait,
liquid or whatever rather than having another liquid.
my dad,
What is that?
I was just
It's a different quantity of measurement of volume. That's still liters, but the only thing is you got a prefix there. Remember all those prefix conversions we did?
I'll fight you.
Bring it. I ain't scared.
I was scared. Look, I got a phone back on it and I'm scared.
Oh, you're so terrified.
I know.
You weigh like 2 pounds.
Any questions on the lab? Going once.
What do we do?
Are we doing percentage? What do we do?
You will do percent error.
Are we following?
But how you're going to do the percent error is look on the back of the bottle that you have right now, man. They should tell you a value for sugar.
Of sugar. That's not healthy.
So in that, we can compare our results with their results. Alrighty, ladies and gentlemen. The whole thing I'm consumed with and wanting to do tomorrow is I want to literally get through and get that data, okay? That's the whole purpose I'm doing. We want to get the data and then we'll work with percent error later on. I don't expect you to have enough time to get the data and get the percent error. So now, ladies and gentlemen, it's time for us to start using these lovely equations that you've been given. Speed of light equals wavelength times frequency, and energy is equal to Planck's constant times frequency. So in this case, we're going to have a lot of fun with these. We're going to do what we did with the mole conversion. We'll start with a really hard problem. So, first off, hard problem. What? Height of wave or electromagnetic radiation here. What type of wave or electromagnetic radiation is a photon? I know you don't know what a photon is right now. We're going to focus on photons more later on, but right now all you need to know is photons is a quantity, it's a quantum of energy. That's all it is. I don't need you to worry about anything else besides that. So is a photon of photon that has, that's what we need to do, that has an energy of 4.65 times 10 to the negative 19 joules. And next to it I will say, if visible light state color Now this is one of those that is a hard and difficult problem. This is not going to be a very simplistic problem, and that's okay. We're going to start hard so you know what we're working towards, and then we're going to jump back and start them easy, okay? So, as you guys know, Tuesday I will not be here. I'm taking my wife for a dentist appointment. She gets to have her root canal done.
Yay. Fun.
And then Friday, I will not be here because I'm going to Marshall University and taking my physics class.
Yay.
No
Hey,
test.
Who's gonna be here then?
quick little quick.
Haven't got it figured out yet.
So, I know this is next month, but like, every day that I miss, I don't know how much it'll be, but I'm gonna get my wisdom tooth removed. Could you like me to do every single like day that I miss?
Yes, send me a message on Remind to remind me though.
Thank you. I appreciate that.
That's the whole purpose of doing this. Like a lot of research out there, a lot of people was like arguing about what I'm doing. It's encouraging people to miss class, but then other people's arguing that it helps the kids out that are in
I can't
class.
help that I actually get my wisdom tooth.
Yeah.
Yeah, no, you're fine, but they're saying it encourages like kids that just like don't want to be here. It encourages them to miss taking the lecture later on. It still don't help. If you're here and then go home and watch it, helps.
I don't know why I have this stuck in my head, but it's like, Joe,
Yep.
watch it, you fucking the song.
All right, so in this is what you got to do. Now, here's the thing. You have to mark your starting point. Your starting point, if you guys haven't figured this out yet, I always give you a number and these math problems that you have to start off with.
I love math.
Yay.
Math is great. Now, in this is the thing. Whenever you're trying to identify the type of wave or tell me the color of light, you're going to need the electromagnetic spectrum. I gave those out yesterday. If you weren't here, you didn't get one. If you were not here, they're right here. In this, look at your electromagnetic spectrum. Look how this thing's broken down. It's broken down in two different segments. It has wavelength and frequency broke down for you. Now in this, I will openly look at you and tell you, you can use frequency and figure this out. But in my opinion, I say use the wavelength. Wavelength is the best way. Wavelength cannot lead you wrong, and this is as to why. Is these numbers down here in wavelength or frequency? Look at your unit. It's wavelength. So in this, I always solve for the wavelength. But in this thing, can I just automatically go and say solve for wavelength? No, I'm starting with energy. Can I get to find wavelength though? Yes. Look what is the same between them. So if I can find frequency here, I can plug frequency in here and find wavelength. So let's start. Energy equals Planck's constant times frequency. I'm going to jump here. I want to see you. I'm hoping you guys are a step above fifth.
I'll show this video.
Oh no, it'll be there for them to see it. It's good to have a little bit of competition.
I can't draw that.
Did anybody in this room right now not have a clue how I just got there?
Well, we're finding.
Okay.
I don't know.
You divide both sides by H.
You divide both sides by Planck's constant. Why do we do that? Because it's Planck's constant times frequency. I got to get frequency by itself, so I have to do the opposite of what's being done to it.
Yep.
So I divide both sides by Planck's constant. Planck's constant cancels on the right side, leaves me with frequency is equal to energy divided by Planck's constant. Now in this, you can plug information in now. So I gave you energy. 4.65 times 10 to the negative 19 joules divided by Planck's constant, which is 6.6 times 10 to the negative 34 joules seconds. It's important to understand that's joules seconds, not joules per second. If you do joules per second, you're going to mess up your numbers. So in this case, joules cancel. So I got joules on the bottom, joules on the top. In that case, this is what I'm being left with. This is just unit-wise here. So joules over joules seconds. So joules cancel, leave me with inverse seconds. Just because these cancel doesn't mean that second pops to the top. It's still on the bottom. It's still in my numerator. Which inverse seconds is equal to seconds to the negative, which is equal to hertz.
Yay. Oh.
So did
Is that the right units for frequency? Yes, I'm going to tell you, I do it all the time in like physics when I get to like 2 dimensions and all that, and the kids are like, how'd you do that? Oh my God. Because it's like on steroids. So in this, you're going to need a calculator. I'm going to tell you right now, you better punch this in your calculator. There are people that have missed this just because they didn't want to punch stuff in the calculator. They get to the quiz and then they mess up on the quiz. Ooh, this will be good.
I can't see. Bro, I know what this. I didn't.
I gotta do the exact same thing.
Punch this in the calculator right now and make sure you can get that number. If you cannot get that number, then you are not doing something right. Now's the time to fix it, not later, now.
Hey, how do we
Yes, sir.
I did parentheses, 4.65. The E. So I hit the second function and the comma button. And remember, that E takes place at the times 10. Then I put negative 19 in parentheses, divided by parentheses, 6.626, little e, negative 34 in parentheses.
Aha. No, I didn't put it in parentheses, but didn't even know they did it.
That's why I always love using my parentheses. The calculator can't use it, cannot read it when wrong if it's in parentheses. Questions?
That's the answer?
No, it's not the answer. We're not done.
I was
What did I ask you for? Answer the question I asked you for.
Yeah.
What type of way?
Okay.
Yes.
The first time I did it without parentheses, I got something in parentheses, but even with these parentheses, I got something in oil.
I'm going to say you are punching something absolutely way wrong in there. You're not using the multiply button, are you?
No. I think I know
Are you using times 10?
that. No, I'm doing the E. I think I'm doing where I want.
All right. There's like killing me. And that makes it worse.
How are we gonna do it?
All right, on this, so that you can follow along with me. Here's how you need to type it in the calculator. You need to hit parentheses. Type the number in, 4.65. We're going to replace the times 10. So second comma. You should have 4.65E. There should be nothing else there besides what's on my calculator. Then you're going to hit the negative button that's right below the 3, 19 in parentheses. From there, you'll hit divide, parentheses, 6.626 second E, negative 34 in parentheses. Is that what you typed? And you didn't get that number?
I did the
Any questions here? If you have questions, you need to ask them. Yes.
How are you getting 6.6?
That is a constant. That is Planck's constant that you must memorize.
It's like Avogadro's number.
You must memorize it.
Yeah.
But say, I know that, like, if everything's made of block,
Be like,
I can't see.
why do you say that? Like,
just what you chose.
why not make it like, it's
Because we wouldn't want to use that terminology. Alright, so we now have frequency, which means we can now use the light equations to give us wavelength. So in this, speed of light equals wavelength times frequency. Now, I need wavelength by itself. We're multiplying here, so we must divide by frequency. Once you do that, frequency cancels out on the right to leave us with wavelength equals the speed of light divided by frequency. Once you do that, you can then plug in 2.98 times 10 to the 8 meters per second divided by frequency, which we just solved for, 7.0178 times 10 to the 14 hertz.
Hey, I have a question.
Yep.
Where'd you get that top in? Yeah.
That is the speed of light. That is the second constant you must memorize. Remember, these two are using constants. Planck's constant and the speed of light. They must be memorized. I'll just leave it here for a second. Alright, from here, before anybody freaks out on me, yesterday in 5th period they were like, how'd you do that? I store my numbers. You see that really big long number right there? I care about accuracy and precision. I will not punch this in a calculator because I can store it to where it'll save that big long number. All I do is I hit right here above the on button, this button that you probably can't really see right there, but it says STO with an arrow. I hit that. That's telling me I'm going to store the number. From there I hit alpha, and now I get to choose whatever letter I want. The green letters on here are what I can choose. I'm going to use A, which is right here at the math key. Right there's the A. And I hit enter. It has now stored that number as A. So I can go alpha A, and you'll see it stored that number. Because now my life's a whole lot simpler. Because I can punch in 2.98 second E to the A, the in parentheses, divide by alpha A. Which gives me 4.2463 times 10 to the negative 7. What's the units?
Meters per second.
That's that on purpose. Look at your units, what you have. You have meters per second divided by hertz. What is hertz equal to? Inverse second. So 1 over second. Whenever you're dividing by a fraction, it's the same thing as multiplying by the reciprocal.
So it's just be
So M over S times, take the reciprocal of this, it's inverse second, so it's S over 1. S is canceled, leaves you with meters.
So I have a question.
Yep.
Never mind. So answered it.
Question on the calculator. No question.
It's not that bad. If that was like the hardest problem, then that ain't that bad.
It's really not that bad. Here's the problem though. A lot of people's not going to catch this.
Matrix over.
This worked out pretty good.
It's in the red, isn't it?
Look at the number up there. 4.2463 times 10 to the negative 7 meters. From there,
We gotta get.
so 10 to the negative 7 meters is from here it's all in this area. Any of that can be negative 7. You're looking at 4.246. So whenever you're looking at this, you have a problem. You're falling here in this visible light. Here's the issue a lot of people miss. What's the units down here? What are you in there? So can you automatically just look at this and catch it? What do you have to do? Prefix conversion. So we have to take this from 4.2463 times 10 to the negative 7 meters. And whenever we do that, we will find ourselves dealing with 4.2463 times 10 to something another. Find something another, do the prefix conversion. We're going from meters to nanometers. Meters is the base unit, so what's the number?
0.
0 minus nano is the new prefix, so what's the number? Negative 9. So we're subtracting the negative, so it's the same thing as adding the positive, which equals 9. But you add to it what you originally start with. Ever mention about stuff that you learn in here, don't forget it, it's going to keep coming up.
2.
Make sure I covered that.
Should be 2. I got 2.
Plus negative 7 equals 2. Now in this case, you can stop there if you wanted to. Me, I don't like that representation of it because it's not the same thing that's over there. So I look and I say 4.2463 times 10 squared, bless you. What's 10 squared? 100 times 4.243.
424.
These numbers are identical. The difference between those two numbers is this number right here, the 424.63 nanometers, is a whole lot easier to look at that and tell where I'm at. So in that case, you're going to look over here at your electromagnetic spectrum.
Bluish, greenish stuff.
If you are watching, close your eyes.
Bam. Get you some.
So alright, in this we came up with 424.63 nanometers. In this case, 424.63 nanometers. Where's that lying at? Here's 400. Here's 500.
Probably about the main.
So you're looking about right there is about 450. So we're going to go to the left of it.
Blue. Indigo. Some blue.
It's the dark.
The truth of it is, the correct answer is going to be indigo.
What if we said blue?
If you said blue in this case, I'm not going to judge you because you can't tell the difference in colors. Truth of it is, I had to sit there and think for a minute. Automatically, the man in me wanted to say blue.
Yeah.
Every girl in here probably would have been like, he clearly don't know his colors. Whole reason I got indigo,
That is.
Roy G. Biv. Here's your blue, indigo, violet.
Yep, that's
If you said blue, you still get credit. If you said indigo, bravo to you, you still get credit. If you said violet, if you looked at me and said green, you are 100% wrong. In this case, watch the video, close your eyes.
What is your colorblind?
How to cook.
You should let me know that now.
He ain't took it.
You ain't thinking? Well, that's a good thing.
If I get one wrong, I'm going.
Yeah, but what would,
Absolutely.
what would you,
Alright, here's the thing though.
what would you do for somebody that was
Do you stop here? No. What were you asked? What type of wave? And if visible light, state color. Photon
There's more.
is visible light color is, you can do blue / indigo. Close enough, whatever.
Now we're done.
Now you're done. Problem's done.
Yeah, the hard ones are easy, but the easy ones are hard.
Once we step back, it's like, oh God, this don't seem right.
You get a feel for it. This is what you'll be doing Tuesday long ago.
Really?
I like when it starts.
Hey, when's our trip? I thought we got on the trip.
What day? What day is
we won't be
what's
here.
the date on Tuesday? Is
I
it
don't
the
know.
15th?
Yeah.
If so, we won't be here. The
Oh,
senior
we're going
prom.
on the WVU trip.
Y'all have a fantastic, wonderful time whenever you come back. All right, any questions here? Awesome. I just got informed by other seniors that we'll not be here on the 15th. If you will not be here on the 15th, fantastic, wonderful,
The
whatever.
22nd and the 24th, we won't be here either.
Fantastic.
Yeah, the 25th we won't be here either.
Or July the 25th. We won't be here.
Okay, there's a hard one.
Still have a stupid game.
I can't do another one.
So I wrote a few notes. You should go in my brain and stress me out, okay?
Yeah, we're not resting. We're behind. We're behind, and here it is. Half my class is screaming off multiple dates in the next 2 weeks that they ain't gonna be here. You kidding me? We ain't resting. Why?
There's like 6 people that need that paper.
Need what paper?
Then he told you.
I said if y'all needed it, sitting right up here.
I can't make it up.
And send somebody that can.
All right, in this, let's look at here.
You do, mate.
What is the wavelength of a photon
Okay.
with a frequency? What?
Can I have people who are in their class arts come take pictures for me?
You've got to be kidding me. For the love of Jesus, people have already been by here today doing it. Make it fast. I'm moving on. What is the wavelength of a photon with a frequency of 3.62 times 10 to the 14th hertz? There's one problem.
Okay. I don't like this, Mr. Hall. Do you know why?
What?
Because there's not a whole bunch that I have to do.
Let's get
It's
that.
like
Come back for
simple.
a second.
Trust me, that'll change. If you want to, you just stick it in slot 30. It does. Got the answer. And what is the amount of energy for a photon? This will be your favorite problem right here. Light that has a frequency of 4.19 times 10 to the 14th hertz. You know what? Let's not do that just so y'all don't get tripped up with your units. Seconds to the -1. In this case, these are very simplistic. These are literally one-stop problems, one step. This is how you know it's one step. You know how in the mole conversions you are either going 2 moles, through moles, or finding moles, right?
Yeah.
These things you're either going through the frequency, or you're going to be starting with the frequency or finding the frequency is one step. In this case, I give you frequency in both of these. They are literally one formula problems.
Do they go together or are they separate? Like,
They're separate. They're separate problems. So in this case, what is the wavelength of a photon with a frequency of 3.62 times 10 to the 14th hertz? So in this, frequency is equal to 3.62 times 10 to the 14th hertz. So in this case, we're trying to find wavelength. Which one of the equations uses wavelength?
Energy, right? It's the C. The little stick.
C equals wavelength times frequency.
That's what I mean.
Yeah, I got you after that once you said it.
Yeah.
It's better to label that as the wavelength.
Yeah.
I'm fine with that. I ain't worried about that. Wavelength equation, if you want to call it that. In this case, we have frequency. We're trying to find wavelength. So they're being multiplied. We got to divide them. So divide both sides by frequency. Frequency cancels on this side. Leaves me with wavelength equal to the speed of light divided by frequency. Speed of light is 2.98 times 10 to the 8 meters per second divided by frequency, which was given to you to be 3.62 times 10 to the 14th hertz.
You gotta, it would be meters.
It'll be meters because hertz and seconds cancel, because hertz is inverse seconds. So now in this, you grab a handy dandy calculator.
Can we do it before you do it?
Yeah, go ahead. I should be, shouldn't
Yeah, but still.
I? I used to be really slow at it. Kids in the class would finish it for me.
Whitney Kirkendall, come to the office.
I got it.
So this isn't one of the cases where you use the alpha thing, right?
No, you don't have, and you don't have to use the alpha thing. I was just showing you that I use it.
Yeah, it's just easier for me to remember like
I'm just determining that it's not this what?
You look so confused. You said,
It is. So,
Alright, you need to punch in the calculator, make sure you can get that. 8.2320 times 10 to the negative 7 meters. Am I finished? Should I do a prefix conversion? You don't have to.
Because it's out, you only have the
You
one
got meters.
meters. You ain't
If I turn that to nanometers, it's just a way of changing the number a little. They're still the same thing because the units are different. If you leave this in meters, what did I ask you for? What is the wavelength? You found wavelength. I did not tell you what to put it in. You can absolutely leave that there. Don't make more steps on yourself than you need to. If I ask you what is the wavelength, find wavelength, leave it, move on. Because if Mr. Hall ever looks at you and says, you didn't put this in nanometers, you get the opportunity to look and say, well, Mr. Hall, you didn't ask for it.
but both gets top right.
Like the inverse seconds thing, like that's meter frequency, right?
Yeah.
Wouldn't, that's not,
Over starting.
that's not visible.
Officer Deskin, come to the office, please.
Correct, it is
Officer
not.
Deskin.
But I didn't ask you with that. In this, what is the amount of energy for a photon of light that has a frequency of 4.19 times 10 to the 14th inverse seconds? In this, frequency, I gave you the number. Look at this unit. It tells you everything you need to know. It's inverse seconds, which is hertz, so it's frequency. Frequency is equal to 4.19 times 10 to the 14th. And at this point, you can change it if you want. You don't have to stay with that inverse seconds. I'm using it because I'm trying to stretch you. I'm trying to pull on you a little bit so that you can see what these are. Inverse seconds. Like I said, this will be your favorite problem, and this is as to why. What is the amount of energy? Just get close to it, Ivory. Energy equals Planck's constant times frequency, which is 6.626 times 10 negative 34 joule seconds times the frequency you were given, 4.19 times 10 to the 14th inverse seconds. Seconds cancel. Punch in the calculator and do it real fast.
Cook, Haley Martin, Ron Anderson, and Breezy St. Clair come to the office.
Chicken scratch.
2.77. 63 times 10 to the negative 19
I realize
joules.
I'm so sorry.
That is the amount of energy. From there, you guys should be good to solve these problems. If you got questions, come see me.
I thought it was dual safety. Other safety.
It is. It's a joule second.
Why is there a line there?
Because it canceled. I got inverse seconds over here.